How the World Works by Cami Nodell and Zachary Zabala. A fundamental limitation of perspective. First off, we will be taking a look at perspective and the limitations of not only our eyes, but any lens with a circular aperture. This covers most cameras and telescopes, along with the vision of every human being on Earth. All of these lenses share what is called an angular resolution limit, which simply means that once two light sources get close enough together, they will merge into one, blurring the image. This is all determined by the size of the aperture, or hole, which is allowing the light to shine through, like the pupil of your eye, for example. Here are some students from Brigham Young University showing how the aperture can create this effect at the same distance just by changing its size. Next, we will take a look at some observations I made along a long warehouse floor up to 460 feet. As you can see, as I back the camera away from the bucket lids, the bottom creates a mirroring effect. The mirror grows larger until the actual lid and its mirror image start to appear to merge together. Another, taken with a flashlight, also shows a mirroring effect followed by them merging into one and then completely disappearing into thin air. David Weiss has captured this with the sun while tracking it with a drone multiple times. This diffraction pattern we see here can be calculated using a formula known as Rayleigh's criterion, and with this we find the average human eye to be around 0.02 degrees. It is radians equals 1.22 times lambda, or the wavelength of light, over d, the diameter of the aperture. The part of the equation which we want to concentrate on is the d. You can see that with it on the bottom, the larger it is, the smaller the final result will be. With this formula I wrote, you can easily figure out how much will always be hidden along your horizon when looking out over a long distance. A minimum, if you will. When a boat gets to only 3 miles away, right around when we are told it should be going over a curve, there is over 5.5 feet that the human eye cannot resolve. You can watch it go out of sight with your eye's vision, then use a lens with a much larger aperture and bring the whole boat back into view. This drawing will show just what is happening and why we can somehow magically see an object which was believed to have gone over a solid barrier horizon without raising our elevation. This is because the larger aperture, the smaller the angle that can be resolved, as the equation showed us. With the average human eye losing the whole boat except for the sail at this point, you can now see why the camera with a much larger aperture can resolve the whole image once again. This is a fundamental limitation of physics pertaining to any lens with a circular aperture. However, this calculation does not take into account any atmospheric distortions and can only become worse in reality, as it is regarding to a perfect nitrogen-oxygen-based atmosphere with no moisture or dust particulates floating about. In short, the appearance of boats going over a curve, the bottom of buildings being cut off, and the luminaries in the sky appearing to set can all be explained over a flat surface with the fundamental limitations of our eyes alone.